Hello there, and welcome to Earth's History, where we trace patterns that span continents and millennia, where we look at ancient monuments separated by oceans and wonder why they seem to share a common language, where we ask questions that challenge everything we think we know about human origins. Tonight, we're embarking on a journey across the entire planet, examining evidence that suggests something extraordinary. What if there was a civilization before recorded history? A culture so advanced and so ancient that it vanished almost completely, leaving behind only scattered clues, monuments, myths, mathematical knowledge, and architectural techniques that seem impossibly sophisticated for their supposed time period? What if these clues are everywhere, hidden in plain sight, waiting for us to finally see the pattern? If you've ever noticed that pyramids appear on almost every continent, if you've ever wondered why cultures that supposedly never met share eerily similar flood myths, if you've ever looked at ancient megalithic structures and questioned how people without modern technology moved stones weighing hundreds of tons, you're picking up on something that orthodox archaeology struggles to explain. There's a pattern in the ancient world, a consistency that crosses geographical and temporal boundaries, a sense that beneath the diverse local cultures we study, there might have been a common source, a predecessor civilization that influenced everyone who came after. Wherever you are right now, I hope you're comfortable, settled, ready to travel the world without leaving your room, to see connections that span from the mountains of Peru to the temples of Cambodia, from the megaliths of Europe to the ruins of the Pacific. Maybe you're lying in bed as the day releases you into night. Maybe you're in that contemplative space where big questions feel natural rather than threatening. Maybe you're ready to suspend disbelief just enough to consider possibilities that mainstream science dismisses. If this global investigation into humanity's forgotten past brings you wonder, if it makes you see ancient sites differently, if it helps you drift into sleep contemplating mysteries that have endured for thousands of years, I'd be grateful if you'd like the video, subscribe to the channel, or share it with someone else who believes that history holds more secrets than we've yet discovered. So settle in. Let your breathing slow like the patient accumulation of evidence across centuries. Let your thoughts drift like ancient mariners crossing vast oceans, carrying knowledge from one shore to another. And let's begin our journey around the world, following the trail of clues that a first civilization might have left, scattered across the face of the earth. The global pattern. Too many coincidences. Let's start with the most obvious pattern, the one that's hardest to dismiss: the worldwide appearance of pyramid structures. When we think of pyramids, we immediately picture Egypt, the Great Pyramid of Giza, the Stepped Pyramid of Djoser, the pyramids of the Valley of the Kings. These are the most famous, the most studied, the iconic images of ancient Egyptian civilization. But Egypt doesn't have a monopoly on pyramids, not even close. Travel west across the Atlantic Ocean to Mesoamerica, and you'll find hundreds of pyramids. The Pyramid of the Sun at Teotihuacan, covering roughly the same base area as the Great Pyramid of Giza. The Temple of Kukulkan at Chichen Itza, with its precise astronomical alignments and mathematical properties. The Pyramids of Tikal in Guatemala, rising above the jungle canopy. The Pyramid of Cholula in Mexico, the largest pyramid by volume in the world, even larger than Giza. These Mesoamerican pyramids are different from Egyptian pyramids in some ways. They're stepped rather than smooth-sided. They have temples on top rather than being solid structures. They served different cultural purposes. But they're undeniably pyramids, massive stone structures with square or rectangular bases tapering to a point or platform, requiring enormous organizational capacity and sophisticated engineering to construct. The conventional explanation is independent invention. A pyramid is a stable structure, wide base, narrow top, that naturally suggests itself when you want to build something tall and impressive with stone blocks. Different cultures, facing similar challenges and working with similar materials, independently arrived at similar solutions. And for many human inventions, this explanation works perfectly. Humans everywhere invented pottery because clay is useful and fire hardens it. Humans everywhere developed agriculture because planting seeds is more reliable than hunting and gathering. Humans everywhere created wheels because circular objects roll. These are simple ideas that multiple cultures would naturally discover independently. But pyramids aren't simple. They require quarrying massive amounts of stone, transporting it to a construction site, lifting blocks weighing tons to significant heights, achieving precise alignments and measurements, organizing thousands of workers over decades, and maintaining social and economic systems capable of supporting such projects. This isn't a simple innovation that obviously suggests itself. It represents a massive commitment of resources, sophisticated engineering knowledge, and complex social organization. And it's not just Egypt and Mesoamerica. Pyramids or pyramid-like structures appear worldwide. South America. The Moche and Chimu cultures of Peru built adobe pyramids. The Corral civilization, dating to around 2600 BCE, contemporary with the Egyptian pyramids, built pyramids in Peru. These structures predate the Inca by thousands of years and suggest that pyramid building in the Americas is as ancient as in Egypt. Sudan. The Nubian pyramids at Meroe and other sites in Sudan number over 200 structures. They're smaller and steeper than Egyptian pyramids, but clearly part of the same architectural tradition. They date from about 700 BCE to 300 CE, much later than Egyptian pyramids, but demonstrating the persistence of the form. China. China has numerous pyramid-shaped structures, mostly burial mounds for emperors and nobles. The most famous is the mausoleum of the first Qin emperor, though the pyramid shape is less pronounced than in Egypt or Mesoamerica. Some researchers claim there are much larger, older pyramids in China that haven't been fully investigated, though these claims are disputed. Indonesia. Gunung Padang, a megalithic site on a hilltop in West Java, has been claimed by some researchers to be an ancient pyramid, possibly dating to 10,000 BCE or earlier based on geological surveys suggesting artificial structures beneath the visible megalithic terraces. Mainstream archaeology is skeptical, viewing the deeper layers as natural geological formations, but the controversy highlights how we might not recognize ancient pyramids if they've been heavily eroded or modified. Europe. While Europe doesn't have true pyramids, it has numerous step pyramids and pyramid-shaped mounds. The Monte Decode in Sardinia is a step pyramid dating to around 2700 BCE. Various burial mounds and megalithic structures throughout Europe show pyramidal geometry, though less pronounced than in other regions. Bosnia. The controversial Bosnian pyramids near Visoko have been claimed by some researchers to be ancient pyramids, possibly the largest and oldest in the world. Mainstream geology considers them natural geological formations called flatirons, hills whose shape superficially resembles pyramids but formed naturally. The debate continues, with passionate advocates on both sides, illustrating how difficult it can be to distinguish heavily eroded artificial structures from natural formations. Pacific Islands. Various Pacific islands have pyramid-like structures or terraced platforms that show sophisticated stone, working, and architectural planning, though these are generally smaller than the massive pyramids of Egypt or Mesoamerica. This global distribution is striking. Even if we dismiss the controversial examples and focus only on undisputed pyramids, Egypt, Mesoamerica, South America, Sudan, we're still left with structures appearing on multiple continents, separated by vast oceans, built by cultures that supposedly never had contact with each other. The mainstream explanation, independent invention, requires that multiple cultures, independently, decided that the pyramid form was the best way to honor their gods, bury their kings, or demonstrate their power, and not just decided this in principle, but implemented it at massive scale, with remarkable engineering sophistication, using similar construction techniques, incorporating similar astronomical alignments, and embedding similar mathematical relationships in their structure's proportions. Is this plausible? Perhaps. Humans are intelligent and creative, and there are only so many ways to stack stones to significant heights. The pyramid is geometrically stable and visually impressive. Different cultures could certainly have invented it independently. But there's another possibility, one that orthodox archaeology resists, but that keeps surfacing in alternative research. What if pyramid building wasn't invented multiple times independently, but was taught? What if there was a source culture, a first civilization that understood advanced architecture and engineering, that either directly built these structures or taught the principles to other cultures, creating a worldwide tradition of pyramid construction that persisted long after the source culture vanished? This hypothesis, often called hyperdiffusionism or the lost civilization theory, suggests that pyramids and other advanced architectural forms spread from a common source, not through independent invention, but through cultural transmission, either by the source culture itself traveling and teaching, or by knowledge being passed down through generations, even after the original culture disappeared. Before we dismiss this as fringe speculation, let's examine more of the evidence, because pyramids are just the beginning of the pattern. The megalithic mystery. Moving mountains pyramids are impressive, but let's talk about something even more puzzling: the massive stone blocks used in ancient construction worldwide. We're not talking about bricks or small stones. We're talking about megaliths, stones weighing tens or hundreds of tons, cut with precision, transported over long distances, lifted to significant heights, and fitted together so tightly that you can't slip a knife blade between them. Baalbek, Lebanon. The Temple of Jupiter at Baalbek incorporates some of the largest stones ever used in construction. The foundation includes 3 stones, called the trilithon, each weighing approximately 800 tons. They're positioned about 7 meters above ground level in the temple platform. Nearly in the quarry lies the stone of the pregnant woman, weighing approximately 1,000 tons, still partially attached to the bedrock. How were 800-ton stones moved and lifted 7 meters in the air? Modern cranes can lift such weights, but it requires specialized equipment. Ancient builders supposedly had only human and animal labor, ropes, levers, and wooden rollers. Experimental archaeology has demonstrated that even 50-ton stones are extremely difficult to move with ancient technology, requiring hundreds of workers and sophisticated techniques. Moving 800-ton stones seems nearly impossible. The Roman builders who constructed the Temple of Jupiter used the trilithon as a foundation, suggesting these enormous stones were already in place, possibly part of an earlier pre-Roman structure. Some researchers argue the trilithon predates the Roman construction by thousands of years, though mainstream archaeology generally dates the entire complex to the Roman period. Sacsayhuaman, Peru. This massive stone fortress above Cusco features walls built from stones weighing up to 200 tons, fitted together with such precision that the joints are nearly invisible and no mortar was needed. The stones have complex, irregular shapes with multiple angles and faces, yet they interlock perfectly. The precision is extraordinary. These aren't simple rectangular blocks stacked in rows. Each stone is unique, with complex three-dimensional contours, yet fits perfectly with its neighbors. Creating such joints would require either cutting both stones simultaneously while holding them together, or creating such precise measurements and cuts that each stone fits perfectly on the first try. Modern stonemasons, using power tools and laser measurements, struggle to replicate this level of precision. How did ancient Andean cultures, supposedly working with bronze tools and stone hammers, achieve it? The Inca, who occupied Cusco when the Spanish arrived, claimed they didn't build Sacsayhuaman. According to their oral traditions, the fortress was built by an earlier people, possibly using techniques the Inca had lost or never possessed. The Spanish conquistadors, seeing the massive stones, believed the walls were built by demons or giants, unable to comprehend how humans could have moved such massive blocks. Ollantaytambo, Peru. Another Inca site featuring megalithic construction with stones weighing 50, 100 tons. The stones for the Temple of the Sun were quarried on a mountain across the valley, transported down one mountain across a river, and up another mountain to the construction site. The stones are andesite, one of the hardest stones to cut and shape. Conventional archaeology proposes that the stones were dragged on wooden sledges by hundreds or thousands of workers, possibly using ramps to overcome elevation changes. But the route includes challenging terrain, river crossings, and significant elevation gain. Some researchers argue that the effort required would be prohibitively enormous, suggesting either different transportation methods or a culture with capabilities exceeding what we attribute to ancient Andeans. Göbekli Tepe, Turkey. This site, dating to approximately 11,000 to 12,000 years ago, features T-shaped megalithic pillars weighing up to 20 tons, carved with sophisticated reliefs of animals. The site predates agriculture, pottery, metalworking, and all the innovations we associate with civilization. It was built by hunter-gatherers, or at least by people we classify as hunter-gatherers, because they predated the agricultural revolution. How did hunter-gatherers, living in small mobile groups with supposedly simple technology, quarry, transport, erect, and carve 20-ton stone pillars? Where did they get the organizational capacity to mobilize the large workforce needed? Why did they invest such enormous effort in creating ceremonial structures rather than focusing on obtaining food? Göbekli Tepe has revolutionized our understanding of human prehistory precisely because it demonstrates capabilities we didn't think existed at such an early date. But it also raises an uncomfortable question. If hunter-gatherers in 10,000 BCE could build Göbekli Tepe, what else were they capable of? Might there be other achievements from this era that we haven't discovered or haven't recognized? Easter Island, Rapa Nui. The famous Moai statues, weighing up to 75 tons, were quarried from volcanic rock, transported across the island, and erected on stone platforms. Some Moai have red stone hats, pukao, weighing up to 12 tons placed on top, meaning these were lifted perhaps 10 meters to be positioned. The island's inhabitants, when Europeans arrived in the 18th century, couldn't explain how the Moai were moved and erected. Their oral traditions said the statues walked to their locations, a claim conventionally interpreted as legend, but that some researchers take more literally, proposing that the statues were walked, upright, using ropes in a technique demonstrated experimentally to be feasible for smaller Moai. But the largest Moai, weighing up to 75 tons, seem impossible to move by walking. And the effort of creating nearly 900 statues on a small island with limited resources raises questions about why such investment was made. What motivated the culture to expend so much energy on statuary? And whether the techniques used were developed locally or imported from elsewhere. Stonehenge and Avebury, England. Stonehenge's largest stones, the sarsens, weigh up to 25 tons and were transported about 25 kilometers from quarries. The bluestones, weighing up to 4 tons, were transported about 250 kilometers from Wales. All were erected in precise positions with astronomical alignments. Avebury's stone circle uses even larger sarsen stones, some weighing 40 tons. The effort of moving these stones using Neolithic technology, wooden rollers, ropes, human labor, would have been immense, requiring coordinated effort by hundreds of workers over extended periods. Why go to such lengths? What motivated Neolithic people to invest generations of effort in creating these stone circles. Conventional archaeology proposes religious or ceremonial purposes, which is plausible but doesn't fully explain the scale of commitment. These weren't simple shrines. They were massive engineering projects requiring sustained organizational capacity and resource mobilization. Karnak, France. This site features over 3,000 standing stones, menhirs, arranged in rows extending for kilometers, dating to the Neolithic period, around 4500, 3300 BCE. Some stones weigh 300 tons. The purpose is unknown, though theories include astronomical observatory, religious processional path, or territorial marker. The sheer number of stones and the effort of erecting them suggests a sophisticated culture with significant organizational capacity. Yet we know very little about who built Karnak or what it meant to them. The pattern of megaliths. Around the world, we find ancient structures built with stones far larger than would seem necessary. If the goal is simply to create a building or monument, why use 100-ton blocks when 1-ton blocks would work? Why transport stones hundreds of kilometers when local stone is available? Why cut and fit stones with precision measured in fractions of millimeters when rougher construction would serve the functional purpose? There seem to be two possible answers. Prestige and demonstration. Cultures built with megaliths to demonstrate power, engineering skill, and organizational capacity. The difficulty was the point, showing that the culture could accomplish something extraordinarily difficult, prove their superiority, honored their gods appropriately, or ensured their monuments would last millennia. Lost techniques. Perhaps moving and working massive stones wasn't as difficult for ancient cultures as we assume. Perhaps they had techniques, ways of using leverage, counterweights, sound vibrations, as some fringe theories propose, or other methods that we've lost or haven't rediscovered. If they had efficient methods for working with megaliths, using massive stones might have been practical rather than purely demonstrative. The first explanation is conventional and reasonable. The second is speculative, but addresses a real puzzle. How did ancient cultures worldwide develop the capability and motivation to work with megaliths? And here's where the first civilization hypothesis becomes relevant. What if megalithic construction wasn't invented independently in dozens of locations, but was a technique taught by a predecessor culture? What if there was an ancient source of knowledge about engineering, about working with stone, about astronomical alignment that was transmitted to various cultures around the world, creating a tradition of megalithic construction that persists in the archaeological record? The precision problem. Measurements in fractions of degrees beyond just the size of stones. Let's talk about precision. Ancient structures worldwide show levels of accuracy in measurement, alignment, and construction that seem to exceed what we'd expect from cultures supposedly using simple tools and techniques. The Great Pyramid of Giza. The base is level to within 2 centimeters over a distance of 230 meters. That's an accuracy of about 0.01%, achieved across an area covering 13 acres. The sides are aligned to the cardinal directions, north, south, east, west, with an error of only about 3 arc minutes, 0.05 degrees. Creating such precision would require accurate surveying instruments, careful measurement, and sophisticated techniques for maintaining level and alignment. The ancient Egyptians supposedly used tools like plumb bobs, water levels, and astronomical observations. These can achieve good accuracy, but the precision demonstrated in the Great Pyramid seems to push the limits of what these simple tools should be able to accomplish. Pyramids' dimensions also encode mathematical relationships. The ratio of the pyramid's perimeter to its height is approximately 2p, the same ratio as a circle's circumference to its radius. Whether this was intentional, demonstrating knowledge of p, or coincidental, resulting from using a particular slope angle that happens to produce this ratio, is debated, But the precision of the construction means that even if coincidental, the ratio is accurately maintained throughout the structure. Machu Picchu, Peru. The stones are fitted with precision comparable to Sacsayhuaman, with joints so tight that mortar wasn't necessary, and blades can't be inserted between blocks. The site is built on a mountain ridge at high altitude, making construction logistically challenging. The quality of construction, achieved in a remote location with difficult access, suggests either abundant resources and labor or exceptionally efficient techniques. Angkor Wat, Cambodia. This massive temple complex, built in the early 12th century, shows sophisticated architectural planning and precise astronomical alignments. The temple's central tower aligns with the spring equinox, with the sun rising directly behind the tower when viewed from the western entrance. The proportions of the temple encode mathematical relationships, and the layout represents a mandala, or cosmic diagram. While Angkor Wat is much more recent than most structures we've discussed, 12th century CE versus multiple millennia BCE for pyramids and megaliths, it demonstrates that precision engineering and astronomical alignment were important to cultures across different times and places, suggesting a persistent tradition of incorporating cosmic knowledge into architecture. Teotihuacan, Mexico. The layout of this ancient city is based on sophisticated urban planning with precise alignments. The Avenue of the Dead, the main north-south axis, is aligned 15.5 degrees east of north, which matches the alignment to the setting of the Pleiades star cluster as it would have appeared in the city's construction period. Around 100 CE, the Pyramid of the Sun is positioned such that its western face aligns with the setting sun on certain days of the year. The city's architecture incorporates a standard unit of measurement, the Teotihuacan meter, about 83 centimeters, used consistently throughout the complex, demonstrating planned construction rather than organic growth. Newgrange, Ireland. This passage tomb, older than the Egyptian pyramids, dating to about 3200 BCE, features a roof box specifically designed so that sunlight penetrates the 19-meter passage and illuminates the inner chamber only during the winter solstice sunrise, for about 17 minutes. The precision required to achieve this effect, aligning a narrow passage perfectly with the azimuth of the rising sun on a specific date, demonstrates sophisticated astronomical knowledge. The pattern of precision. Worldwide, ancient structures show levels of measurement, accuracy, astronomical alignment, and mathematical encoding that seem to exceed what we expect from their supposed technological level. This could mean ancient people were more capable than we credit. Perhaps sophisticated surveying, astronomical observation, and mathematical knowledge were more widespread in the ancient world than conventional history acknowledges. Perhaps ancient engineers were simply excellent at what they did, achieving precision through careful work and accumulated expertise rather than advanced technology. Inherited knowledge. Perhaps the precision reflects knowledge inherited from a predecessor culture, a first civilization that understood sophisticated mathematics, astronomy, and engineering, and taught these principles to successor cultures. The consistency of precision across cultures and time periods might indicate a common source of technical knowledge. We're seeing patterns that aren't there. Perhaps some of the precision is coincidental, the result of modern researchers finding mathematical relationships in dimensions that weren't intentionally encoded. Perhaps ancient builders didn't intend to encode pi or phi or astronomical cycles, but these appear in the structures by accident, and we're over-interpreting. This third possibility deserves consideration. Humans are pattern-seeking creatures, and we can find numerical relationships in almost any structure if we look hard enough. A certain amount of skepticism about claimed mathematical encoding is healthy, but the astronomical alignments are harder to dismiss. When Newgrange's passage illuminates only on the winter solstice, that's not coincidence. It's deliberate design requiring astronomical knowledge. When the Great Pyramid's shafts point to specific stars important in Egyptian religion, that's intentional. When temples worldwide align with solstices, equinoxes, or particular stellar risings and settings, we're seeing systematic incorporation of celestial knowledge into architecture. This suggests ancient cultures possessed sophisticated astronomical knowledge and considered it important enough to incorporate into their most significant structures. The consistency of this practice worldwide might indicate a common tradition, possibly inherited from a predecessor culture that emphasized astronomical observation and its incorporation into sacred architecture. The mythological parallel. Stories that travel, let's shift from physical structures to intangible culture. Mythology. If there was a first civilization that influenced cultures worldwide, we'd expect to find not just similar architecture, but similar stories, similar myths, similar religious concepts appearing in geographically dispersed cultures. And we do. The global flood myth. We touched on this earlier, but it deserves deeper examination. Over 500 cultures worldwide have flood traditions describing a catastrophic deluge that destroyed an earlier world, with a few survivors escaping, usually with divine help or foreknowledge, to repopulate the earth. The similarities across these myths are striking. A world-destroying flood sent by gods or natural catastrophe. Warning given to one virtuous man, Noah, Utnapishtim, Deucalion, Manu, etc. Construction of a boat or ark to escape. Saving of animals, seeds, or human companions. Birds released to find dry land. Dove, raven, swallow. Landing on a mountain after waters recede. Sacrifice to gods after surviving. Repopulation of the earth from survivors. These narrative elements appear in Mesopotamian flood myths, Epic of Gilgamesh, Hebrew tradition, Noah, Greek mythology, Deucalion, Hindu texts, Manu, Chinese tradition, Gun Yu, Native American traditions, various tribes, Aztec mythology, Inca traditions, and Aboriginal Australian stories. The conventional explanation is that floods are common natural disasters, so flood stories naturally appear in many cultures. But the specific narrative elements, the righteous survivor, the ark, the birds, the mountain, appear consistently across cultures that supposedly never had contact. This consistency suggests either remarkable coincidence or some kind of cultural transmission. Could the flood myths preserve actual historical memory of post-Ice Age sea level rise? Between roughly 12,000 and 7,000 years ago, melting ice sheets caused sea levels to rise by about 120 meters, flooding vast coastal areas where humans likely lived. This would have been catastrophic for coastal communities, forcing mass migrations and destroying settlements. If oral traditions can preserve memories for thousands of years, and research on Aboriginal Australian oral traditions suggests they can preserve geographical information for 7,000, 10,000 years, then flood myths might be cultural memories of this real historical event, transformed through countless retellings into mythological narratives, but retaining the core memory of catastrophic flooding that destroyed the world people knew. If this interpretation is correct, it means cultures worldwide preserved memories of the same catastrophic period, the end of the Ice Age, suggesting either a widespread distribution of human populations that experienced and remembered this event, or a cultural network that transmitted these stories across populations. The dying and rising god. Many ancient religions feature a deity who dies, often violently, descends to the underworld, and returns to life, with this death and resurrection tied to agricultural cycles or cosmic renewal. Osiris, Egypt, killed by his brother Set, body dismembered, resurrected by Isis, becomes lord of the underworld. Tammuz, Dumuzi, Mesopotamia. Dies and descends to the underworld, mourned by Ishtar, cyclically returns, Dionysus, Greece. Torn apart and consumed, reborn, associated with wine and ecstasy, Adonis, Greek Phoenician. killed by boar, mourned by Aphrodite, cyclically returns, Attis, Phrygia, dies, versions vary, associated with death and rebirth of vegetation Balder, Norse, killed by mistletoe, descends to hell, prophesied to return after Ragnarok Quetzalcoatl, Mesoamerica, dies, descends to underworld, gathers bones to create humanity, associated with cyclical return. The pattern is consistent. A god important to the culture's religious system dies, descends to a realm of death, and either returns to life or becomes associated with cyclical renewal. The death is often violent or sacrificial. The god's death and return are tied to natural cycles, seasons, agriculture, astronomical events. This pattern could reflect independent recognition of natural cycles. Vegetation dies in winter, returns in spring. The sun dies at winter solstice, is reborn with lengthening days. Death and rebirth are universal human experiences. Different cultures, observing the same patterns, created similar mythological narratives, but the specific details are remarkably consistent. The god is often dismembered. A goddess, lover, mother, or sister mourns and seeks the dead god. The death involves betrayal or conflict with another deity. Annual festivals commemorate the death and resurrection with specific rituals. This consistency suggests cultural transmission or common source. Perhaps these myths spread from one originating culture to others through trade, migration, or conquest. Or perhaps they derive from a common, more ancient source of first civilizations' religious concepts that were adopted and adapted by successor cultures. The world tree. The cosmic tree connecting underworld, earth, and heaven appears in mythologies worldwide. Yggdrasil, Norse. Ash tree with roots in 3 wells, branches extending through the 9 realms, the Hulupu tree, Mesopotamian. In the Gilgamesh cycle, a tree sacred to Inanna, the tree of life, tree of knowledge, Abrahamic. In Eden, connecting earthly and divine realms, the Kalpavriksha, Hindu. Wish-fulfilling tree in Hindu cosmology, Siba tree, Mayan. Sacred tree with roots in Xibalba, underworld. Trunk in earthly realm, branches in heavens, world tree, Siberian shamanic traditions. Central to shamanic cosmology across Siberian cultures. Axis mundi concepts in numerous other traditions. The world tree represents cosmic structure, vertical axis connecting different realms, roots reaching down, branches reaching up, often with specific animals or spirits associated with different parts of the tree. It serves as a pathway for souls, gods, or shamans traveling between worlds. This concept appears so consistently that it suggests either universal human psychology, trees are prominent features, naturally become metaphors for cosmic structure, or cultural transmission from a common source. The 7 sages or culture heroes. Many traditions describe wise beings who came from elsewhere to teach civilization, agriculture, writing, astronomy, law, architecture, Apkallu, Mesopotamian. 7 sages who taught civilization before the flood wands, Babylonian. Fishman who emerged from sea to teach civilization to humans, Viracocha. Andean, creator god who taught agriculture and civilization to humans, Quetzalcoatl, Mesoamerican. Feathered serpent who taught civilization, Calendrix, and agriculture. The Watchers, Judaic tradition. Angelic beings who taught humans forbidden knowledge, Prometheus, Greek. Titan who gave fire and civilization to humanity, Osiris Thoth, Egyptian. Gods credited with teaching civilization to Egyptians. The pattern. Civilizing knowledge came from outside, from beings who were not ordinary humans, but gods, demigods, or visitors. They taught fundamental skills: agriculture, metallurgy, writing, astronomy, mathematics, law, architecture. Often they came from across the water or from the sky. Sometimes they were associated with flood narratives, appearing before or after the catastrophe. These myths could be allegorical explanations for the development of civilization, attributing human innovations to divine sources, because our ancestors couldn't imagine primitive humans developing such knowledge independently. This is the conventional interpretation. But there's another possibility. Perhaps these myths preserve memories of actual knowledge transmission from a predecessor culture, not from gods or aliens, but from survivors of an earlier, more advanced civilization who lived through some catastrophe, possibly the end of the Ice Age and associated flooding, and taught their knowledge to more primitive contemporary cultures, becoming remembered as wise teachers, culture heroes, or gods. The pattern in mythology. The consistency of mythological themes across dispersed cultures suggests either universal human psychology. Certain myths arise naturally from human cognition, common experiences, and observation of nature. Flood myths arise because floods happen. Dying and rising gods reflect seasonal cycles. The world tree reflects the visual prominence of trees and the human need to structure cosmology vertically. Cultural diffusion. Myths spread through trade, migration, and cultural contact. A myth originating in one region gradually spreads to others, being adapted and modified, but retaining core elements. Common ancient source. The consistency reflects inheritance from a first civilization whose myths, religious concepts, and knowledge were transmitted to successor cultures, becoming embedded in diverse mythological traditions. The third option is the most controversial, but also potentially the most interesting. If there was a widespread predecessor culture that experienced catastrophic destruction, possibly at the end of the Ice Age, survivors dispersing to different regions might have carried common myths with them, which evolved differently in each region, but retained core elements, creating the patterns we observe. The knowledge transfer, mathematics and astronomy. Let's examine something more concrete than mythology. Mathematical and astronomical knowledge appearing in ancient cultures at sophistication levels that seem to exceed what we'd expect for their time period. Ancient astronomy. The precession of the equinoxes, the slow wobble of Earth's axis over approximately 26,000 years, requires centuries of careful astronomical observation to discover. You need to compare current stellar positions with accurate records from hundreds of years earlier, note the drift, and calculate the rate of change. The Greek astronomer Hipparchus is credited with discovering precession around 127 BCE, based on comparing his observations with Babylonian records from centuries earlier. This is conventionally considered the first scientific discovery of precession. But there's evidence that earlier cultures knew about precession. Egypt. The slow drift of stars over centuries was apparently known. The Great Year concept in Egyptian texts possibly refers to precessional cycles. Different stars served as the North Pole star in different epochs, which Egyptian texts seem to acknowledge. Vedic India. Ancient Sanskrit texts contain astronomical references that, if taken literally, suggest observations made at times when precession would have positioned constellations differently than in the historical period when the texts were written down, possibly indicating knowledge of precession or very ancient observational origins. Maya. The Maya long count calendar's enormous time spans, over 5,000 years in a single cycle, and the emphasis on cyclical time might reflect knowledge of long astronomical cycles, including precession. Giorgio de Santillana and Hertha von Deschend, in their controversial book Hamlet's Mill, argued that many ancient myths encode astronomical information, including precession. They interpreted mythological narratives about the succession of ages, shifting cosmic structures, and cyclical destructions as allegories for precessional ages, the slow shift of the zodiacal constellation visible at the spring equinox, which cycles through all 12 zodiac signs over 26,000 years. Their interpretation is controversial. Many scholars argue they're overinterpreting myths, finding astronomical meaning where there's just narrative. But the book raises important questions. How did ancient cultures discover precession if they didn't have written records spanning centuries? Why would they encode such information in myths rather than recording it explicitly? One possibility: if there was a first civilization with long-established astronomical observations, records spanning not just centuries but millennia, they would have discovered precession early and recognized its importance. If this civilization collapsed, some astronomical knowledge might have been preserved in mythological form, as stories that encoded critical information in memorable narratives, allowing the knowledge to survive through oral tradition, even if the scientific understanding was lost. Advanced mathematics. The Great Pyramid of Giza encodes mathematical relationships that suggest sophisticated knowledge. The perimeter-to-height ratio approximating 2p dimensions that encode the speed of light in a specific units system. The golden ratio, phi, appearing in various proportions, relationships to Earth's dimensions. Some researchers claim the pyramid is a scaled model of the Northern Hemisphere. Some of these are probably coincidental or result from modern researchers finding patterns in numbers, but the p relationship is striking, appearing accurately enough that it's difficult to dismiss as pure accident. The Mayan calendar system demonstrates sophisticated mathematics, including the concept of zero, invented independently of the Old World zero concept, and highly accurate astronomical calculations. The Mayan solar year calculation, 365.2420 days, is more accurate than the Julian calendar used in Europe until the 16th century, 365.25 days, and very close to the actual solar year, 365.2422 days. How did the Maya achieve such accuracy without telescopes or precision instruments? Through patient observation over many generations, carefully recording celestial movements, recognizing patterns, calculating cycles. This demonstrates that ancient cultures could achieve remarkable precision through dedication and careful work. But it also raises questions about continuity. If achieving this accuracy requires observations spanning many generations, what happens when civilizations collapse? Is the knowledge preserved, or must successor cultures rediscover it through new centuries of observation? The Antikythera mechanism. This extraordinary device, recovered from a Roman-era shipwreck off the Greek island of Antikythera and dating to approximately 100 BCE, is a complex mechanical computer designed to calculate astronomical positions and predict eclipses. The mechanism features dozens of bronze gears with specific tooth counts designed to model astronomical cycles. The Metonic cycle, 19 years. The Saros cycle, 18 years for eclipse prediction. The Kallipic cycle, 76 years, and others. It's essentially an analog computer using mechanical gears to perform complex astronomical calculations. The sophistication is staggering. This level of gear technology doesn't appear again in historical records until medieval Islamic and European mechanical clocks over 1,000 years later. How did ancient Greeks develop this capability? Where are the prototypes, the earlier versions, the developmental history of such mechanisms? The Antikythera mechanism demonstrates that ancient Greeks possessed mechanical engineering capabilities far beyond what we see in most surviving artifacts. It raises the possibility that much ancient technology has been lost, either because it was made from materials that don't survive, organic materials, corroded metals, or because we haven't recognized surviving artifacts as technological devices rather than decorative objects, and it raises questions about knowledge transmission. The Greeks credited much of their astronomical and mathematical knowledge to earlier sources, the Babylonians, the Egyptians, others. Were there even earlier sources? Did Greek knowledge ultimately derive from a first civilization that developed sophisticated astronomy and mathematics? with this knowledge being transmitted through intermediate cultures until reaching classical Greece. Navigational knowledge. Ancient seafaring cultures, Polynesians, Phoenicians, Vikings, others, demonstrated remarkable navigational capabilities, crossing vast ocean distances without compasses, sextants, or charts, using only observations of stars, sun, ocean swells, and wildlife. Polynesian navigators settled islands scattered across the vast Pacific Ocean, finding tiny islands separated by thousands of kilometers of open water. This requires sophisticated knowledge of stellar navigation, understanding of ocean currents and wind patterns, and ability to maintain course over weeks at sea. How was this knowledge developed? Through generations of careful observation, trial and error, and cultural transmission through apprenticeship and oral tradition. This is well documented and understood, but some researchers have proposed that transoceanic contact occurred earlier and more extensively than conventionally acknowledged. Evidence includes sweet potato, a South American plant, appearing in Polynesia before European contact. Possible genetic evidence of Native American ancestry in some Polynesian populations claimed similarities between ancient Mediterranean and New World cultures. Most of this evidence is controversial, with mainstream archaeology skeptical of significant pre-Columbian transoceanic contact, except for Viking voyages to North America around 1000 CE, which are well documented. But if such contact occurred, it would indicate that ancient navigational knowledge was more sophisticated than often credited, that ancient mariners could deliberately cross oceans rather than reaching distant shores only through accidental drift voyages. This would imply a network of knowledge and capability extending across vast distances, possibly preserving and transmitting knowledge from earlier seafaring traditions. The pattern in knowledge. Ancient cultures worldwide demonstrate mathematical, astronomical, and navigational knowledge that seems sophisticated for their supposed technological level. This could indicate ancient people were smarter than we think. The simplest explanation is that ancient cultures achieved these things through intelligence, observation, and dedication. They were as smart as modern humans, since they were anatomically identical, and simply applied their intelligence differently. Inherited knowledge. The sophistication might reflect knowledge inherited from a predecessor culture, a first civilization that developed mathematics, astronomy, and navigation to high levels and taught these principles to successor cultures. The knowledge would degrade over generations as understanding was lost, but practical applications, calendars, navigation techniques, architectural principles might persist. We're projecting modern assumptions. Perhaps our surprise at ancient capabilities reflects our own assumptions about what primitive cultures should be capable of. If we expect little, we're impressed by anything. If we judge ancient cultures by their own standards rather than ours, their achievements might be exactly what we'd expect from intelligent humans working within their technological constraints. All three explanations likely contain truth. Ancient people were intelligent and capable. Some knowledge might have been inherited from earlier cultures, and our assumptions about ancient capabilities are sometimes wrong. But the global pattern, similar structures, similar myths, similar mathematical knowledge appearing in geographically dispersed cultures, suggests something more than just independent intelligence. It suggests either widespread cultural contact at very early dates, or inheritance from a common source, or both. The geological evidence, catastrophe and continuity. Let's shift from cultural evidence to geological evidence, because if there was a first civilization that was destroyed, we should see evidence of the catastrophe that destroyed it. The Younger Dryas event. Around 12,800 years ago, Earth's climate abruptly shifted. The warming trend that had been melting Ice Age glaciers suddenly reversed. Temperatures plummeted back to near glacial conditions. This cold period, called the Younger Dryas, lasted about 200 years before ending just as abruptly around 11,600 years ago, when temperatures rapidly warmed again. The Younger Dryas is well documented in ice cores, sediment cores, and geological evidence worldwide. It was a real, dramatic climate event that affected the entire planet. What caused it? The conventional explanation involves changes in ocean circulation. As ice sheets melted, massive amounts of fresh water flowed into the North Atlantic, disrupting the thermohaline circulation, the ocean conveyor belt that distributes heat globally. This disruption caused the Northern Hemisphere to cool rapidly, despite the ongoing deglaciation. But in 2007, researchers proposed an alternative explanation, the Younger Dryas impact hypothesis. They argued that Earth was struck by fragments of a disintegrating comet around 12,800 years ago, causing widespread wildfires, atmospheric cooling, and triggering the Younger Dryas climate event. Evidence cited includes a sediment layer dating to 12,800 years ago, containing markers suggesting cosmic impact, nanodiamonds, magnetic spherules, carbon spherules, iridium anomalies, evidence of widespread wildfires at the same time, mass extinction of North American megafauna, mammoths, mastodons, saber-toothed cats, etc., coinciding with the Younger Dryas beginning disruption of the Clovis culture, the earliest widespread culture in North America. The hypothesis immediately became controversial. Critics argued that the supposed impact markers could have other explanations, that some evidence was misidentified, that the layer wasn't consistently found at the right date across sites, and that no impact craters had been found. The debate has been contentious, with numerous papers published supporting and challenging the hypothesis. As of now, the mainstream scientific consensus remains skeptical, favoring the ocean circulation explanation for the Younger Dryas, but the impact hypothesis continues to be investigated and debated. Why does this matter for our discussion? Because if Earth was struck by comet fragments 12,800 years ago, it would have been precisely the kind of catastrophe that could destroy an advanced civilization. Multiple impacts or airbursts across the Northern Hemisphere, massive wildfires, tsunamis from ocean impacts, atmospheric dust causing rapid cooling. Any civilization existing at that time would have been devastated. Survivors would have been scattered, infrastructure destroyed, knowledge lost. What survived would be fragments, stories of catastrophe, bits of technical knowledge, refugees carrying what they could to new locations, attempting to preserve something of their culture while struggling to survive in a world suddenly plunged into crisis. This would explain the global flood myths. If there was a major impact event around 12,800 years ago, it would have been catastrophic enough to create worldwide memories, preserved in oral traditions for thousands of years, becoming the mythological deluge narratives we see in diverse cultures. It would explain the sudden appearance of agriculture around 11,000, 10,000 years ago, not as humanity's first invention of agriculture, but as the reinvention or readoption of agriculture by survivors of a catastrophe, people who had to reestablish food production systems after their previous world was destroyed. It would explain Göbekli Tepe, not as hunter-gatherers spontaneously building megalithic structures, but as survivors of a more complex society, possibly refugees from destroyed coastal civilizations, creating ceremonial centers to preserve their traditions and maintain social cohesion during a time of crisis. Sea level rise. Between roughly 12,000 and 7,000 years ago, melting ice sheets caused sea levels to rise by about 120 meters. Vast areas of continental shelf that were dry land during the Ice Age were submerged. These areas are now underwater, inaccessible to most archaeology, unexplored. During the Ice Age, these continental shelves were prime human habitat, coastal environments with access to both marine and terrestrial resources, moderate climates, diverse ecosystems. If there were advanced Ice Age cultures, they most likely lived on these coasts. which are now under 50 to 100 meters of water. All evidence of Ice Age coastal settlements would be underwater, possibly buried under meters of marine sediment. Conventional archaeology has focused on inland sites because those are accessible, but this creates a bias. We're studying the marginal locations, the inland camps and refugees, while the main population centers were coastal and are now invisible. Some underwater archaeology has begun exploring submerged sites. Off the coast of India, in the Gulf of Kambat, surveys have identified what appear to be structural remains at depths suggesting occupation during lower sea levels. Various sites in the Mediterranean, off Japan, and elsewhere have revealed submerged structures, though their age and nature are often debated. The Black Sea was a freshwater lake during the Ice Age. Around 7,500 years ago, the Mediterranean breached the Bosporus and flooded the basin, possibly catastrophically. Some researchers have proposed this inspired Near Eastern flood myths. But underwater archaeology is expensive, technically challenging, and covers only tiny fractions of the vast submerged landscapes. We're essentially trying to find needles in oceanic haystacks. It's entirely possible that substantial Ice Age settlements existed on now submerged coasts and simply haven't been found yet. Erosion and time, even on land, evidence of very ancient structures might not be recognizable. After 10,000 or 12,000 years, stone erodes, organic materials decay, metals corrode. What would remain of a city after 12,000 years? Stone structures might survive, but heavily eroded, possibly so degraded they'd be mistaken for natural formations. Worked stones might be scattered, their context lost. Sophisticated artifacts might corrode away completely. Books, if they existed, would have disintegrated unless sealed in extraordinarily dry environments. We might literally be standing on or walking past evidence of ancient civilizations without recognizing it, because we're not looking for it. Orthodox archaeology doesn't expect to find sophisticated structures from 12,000 plus years ago, or because it's degraded beyond easy recognition. The Bosnian pyramid controversy illustrates this problem. Are the hill formations near Visoko ancient pyramids, heavily eroded but still showing artificial features? Or are they natural hills whose shape happens to resemble pyramids? Without clear artificial features like blocks, mortar, or internal chambers, it's difficult to prove either way. If there were many heavily eroded structures from 12,000 plus years ago, we might dismiss most as natural formations, simply because they don't show obvious artificial features. We might be systematically missing evidence because we're not looking in the right way or not recognizing what we're seeing. The pattern in catastrophe. If there was a first civilization that was destroyed around 12,800 years ago by a cosmic impact or other catastrophe, and if survivors scattered to various regions where they taught their knowledge to less advanced contemporary cultures, we'd expect to see global flood myths preserving memories of the catastrophe, sudden appearance of advanced knowledge, agriculture, architecture, astronomy, around 11,000, 10,000 years ago as survivors transmitted their knowledge similarities in architecture and culture across geographically dispersed regions, reflecting common origin, very limited physical evidence of the first civilization itself, because coastal sites are submerged and inland sites are eroded or unrecognized, possible anomalous structures, predating conventional chronologies, representing either pre-catastrophe construction or immediate post-catastrophe building by survivors. This pattern arguably matches what we see, though it's open to other interpretations. The question is whether we're seeing the signature of a destroyed first civilization, or whether we're projecting a narrative onto evidence that has simpler explanations. The map evidence. Knowledge of a lost geography. Let's examine one of the more intriguing pieces of circumstantial evidence. Ancient and medieval maps that seem to show geographical knowledge that shouldn't have existed at the time the maps were made. The Piri Reis Map, 1513. This map, drawn by Ottoman admiral and cartographer Piri Reis, shows the Atlantic Ocean, the coasts of Africa and South America, and possibly Antarctica. The map is based on about 20 source maps, some dating to the time of Alexander the Great or earlier, according to Piri Reis's notes. The controversial aspects. The southern landmass on the map has been interpreted by some researchers as Antarctica, showing the coastline as it would appear without ice, with geographical features that match the subglacial topography revealed by modern seismic surveys. Antarctica wasn't officially discovered until 1820, and its ice-free coastline hasn't been visible for thousands of years. If the map does show Antarctica ice-free, it would require source maps created at a time when Antarctica was accessible and ice-free, which would be over 6,000 years ago at minimum. The skeptical interpretation. The southern landmass is probably just a distorted depiction of South America's coast, extended southward based on speculation about an undiscovered southern continent, Terra Australis, hypothesized by ancient and medieval geographers. The ice-free coastline, matching Antarctica's subglacial geography, is wishful interpretation. Seeing patterns in ambiguous lines, Piri Reis's notes about ancient sources might be exaggerations, attempts to give his work authority by claiming ancient provenance, the Orontius Linnaeus map. 1531. This map shows Antarctica, clearly labeled Terra Australis, with a shape remarkably similar to the actual continent, including interior features like mountain ranges and rivers that would only be visible if the ice were absent. The same debate applies. Is this really showing Antarctica, implying ancient source maps? Or is it a speculative depiction of a hypothesized southern continent that happens to somewhat resemble Antarctica by coincidence? The Boache Map, 1754. Felipe Boache's map shows Antarctica divided into two landmasses separated by a channel. This matches Antarctica's actual subglacial geography. West Antarctica is separated from East Antarctica by a deep channel currently filled with ice, but which does exist beneath the ice sheet. Boache stated he was depicting the continent as it would look without ice, based on theoretical considerations. But how did he know about the channel? This wasn't confirmed until the 1950s, when seismic surveys mapped the subglacial topography. Skeptics note that Boache was speculating based on limited data, and his speculation happened to be somewhat correct by coincidence. Advocates argue the accuracy suggests Boache had access to older source maps that preserved knowledge of Antarctica's ice-free geography. The pattern in maps. If the interpretations of these maps as showing ancient geographical knowledge are correct, they would suggest a maritime culture that explored Antarctica when it was partially ice-free, creating maps of the coastline. These maps were preserved, copied, and passed down through various civilizations: Phoenician, Egyptian, Greek, Roman, Byzantine, Islamic. European Renaissance cartographers had access to these ancient maps and incorporated their information. This would require a sophisticated maritime culture existing at least 6,000 to 12,000 years ago, when Antarctica was partially ice-free, capable of long-distance ocean voyages, accurate mapping, and knowledge preservation. Critics point out that Antarctica hasn't been completely ice-free for millions of years. Even during warmer interglacial periods, it retains substantial ice cover. The map interpretations are highly subjective. Seeing what researchers want to see in ambiguous cartographic features, it's more plausible that Renaissance cartographers were speculating about unexplored regions, sometimes guessing correctly by chance, than that they had access to ancient maps showing ice-free Antarctica. The debate illustrates a broader challenge. How do we distinguish genuine ancient knowledge, preserved in later copies, from speculation and coincidence? Without finding the original ancient maps, if they existed, we can't definitively prove their existence. but we also can't definitively disprove it. The astronomical alignments. A global grid. Many ancient structures are aligned with astronomical events, solstices, equinoxes, rising or setting positions of particular stars. This is well documented and generally accepted. But some researchers have proposed something more, that sites worldwide are positioned according to a global grid based on sophisticated geodetic knowledge. The Giza Meridian. The Great Pyramid of Giza sits at latitude 29.97992 degrees north. The speed of light in vacuum is 229,792,458 meters per second. The similarity in numbers has led some researchers to propose that ancient Egyptians knew the speed of light and encoded it in the pyramid's location. This is almost certainly coincidence. The speed of light measured in meters per second produces this number because the meter was defined, originally, as 1/10,000,000th of the distance from the North Pole to the equator. The latitude in degrees and the speed of light in meters per second both relate to Earth's dimensions in ways that create numerical coincidence, not intentional encoding. But the broader question remains interesting. Did ancient builders choose locations based on geodetic considerations? Understanding of Earth's size, shape, and geographical relationships? Great circle alignments. Some researchers have noted that certain ancient sites lie on great circle routes, the shortest paths between points on a sphere, that connect multiple significant locations. For example, a great circle passing through Giza also passes near Petra, Persepolis, and other ancient sites. Various alignments connect Nazca, Easter Island, Angkor Wat, and other locations. The problem is that with thousands of ancient sites worldwide, you can draw great circles through multiple sites simply by chance. Any 3 sites define a unique great circle, so finding apparent alignments isn't surprising or significant without additional evidence that the alignments were intentional. The equator and tropics. Some sites are positioned at geodetically significant latitudes. The Tropic of Cancer, 23.5 degrees N, the northernmost latitude, where the sun can be directly overhead, passes near various ancient sites. The equator passes through regions with ancient civilizations in Ecuador, Kenya, Indonesia. But the tropics and equator are defined by solar geometry, so it's natural that cultures would recognize these latitudes as significant and might place important structures there. This doesn't require sophisticated geodetic knowledge, just observation of the sun's behavior. The pattern in alignments. If ancient cultures possessed sophisticated geodetic knowledge, understanding of Earth's size, shape, and geographical relationships, and used this knowledge to position monuments, it would suggest inherited knowledge from a predecessor culture with advanced geography and astronomy, a global perspective on Earth's geography, treating the planet as a unified system, possible coordination or communication between cultures at vast distances. This is speculative and lacks strong evidence. The claimed alignments are often selective, cherry-picking sites that fit patterns while ignoring those that don't. The statistical significance of alignments is usually not rigorously tested, and plausible alternative explanations, coincidence, common astronomical observations, natural preference for certain locations, exist. But the question remains intriguing. If there was a first civilization with advanced maritime capabilities, they would have understood Earth's geography at a global scale. They might have positioned their main centers at geodetically significant locations. If successor cultures built on or near these sites, they might unknowingly preserve this ancient geographical pattern. The technology question. Lost techniques. Throughout this discussion, we've encountered ancient technologies that seem sophisticated or even impossible for their supposed time period. Moving 800-ton stones at Baalbek cutting granite with millimeter precision in Egypt, and Peru creating the Antikythera mechanism's complex gearing, achieving astronomical alignments requiring sophisticated measurement, producing metal alloys that seem advanced for Bronze Age cultures. The question is, are these technologies genuinely inexplicable, or are we underestimating ancient capabilities? Stoneworking. Experimental archaeology has demonstrated that ancient stoneworking techniques, while labor-intensive, can achieve impressive results. Using copper tools with abrasive sand, ancient Egyptians could cut granite. Using stone hammers and wooden wedges, ancient cultures could quarry and shape large blocks. Using levers, ramps, and enormous numbers of workers, massive stones could be moved and lifted. These techniques are slow and require enormous labor, but they work. Perhaps the explanation for ancient megalithic construction is simply that ancient cultures were willing to invest far more labor than we'd consider reasonable, because they valued these structures highly enough to devote generations of effort. However, some features still puzzle researchers. The precision of granite box drilling in Egypt, with cores showing characteristics suggesting advanced drilling techniques. The extreme hardness of diorite bowls and vases in Egypt, requiring very hard tools to shape. The speed of construction suggested by chronologies. If the Great Pyramid was built in 20 years as conventionally dated, it required placing one block every few minutes, which seems implausibly fast. These puzzles don't necessarily require lost advanced technology. They might just mean our reconstructions of ancient techniques are incomplete, that ancient craftspeople had tricks and methods we haven't figured out yet, that the labor force was larger or more efficient than we estimate. But they leave room for speculation about whether some techniques have been lost, whether ancient builders knew methods we don't, whether there was inherited knowledge from a predecessor culture with more sophisticated tools and techniques. Metallurgy. Some ancient metal artifacts show surprisingly sophisticated metallurgy. The Iron Pillar of Delhi, dating to around 400 CE, is made of unusually pure iron that hasn't rusted despite centuries of exposure to weather. Some Bronze Age artifacts show evidence of techniques like case hardening, cast welding, or complex alloy compositions. The Damascus steel technique, producing legendary sword blades with distinctive patterns and properties, was lost and has been difficult to fully replicate despite modern metallurgical knowledge. These don't prove lost civilizations, but they demonstrate that ancient metallurgists achieved things we struggle to explain or replicate. Metallurgy is cumulative. Techniques develop over generations, with each generation building on previous knowledge. If knowledge chains are broken by war, collapse, or cultural disruption, techniques can be lost. If there was a first civilization with advanced metallurgy, survivors might have carried some knowledge to successor cultures, but without the full infrastructure and accumulated expertise, only partial techniques would survive, creating the pattern we see. Occasional sophisticated artifacts appearing in contexts that seem too early or too primitive to explain them. Chemistry and materials. Ancient cultures used various chemical processes. Egyptian mummification required sophisticated understanding of preservatives, desiccants, and organic chemistry. Roman concrete, used in structures like the Pantheon and aqueducts, has properties modern concrete struggles to match, particularly longevity and performance in seawater. Various ancient dyes, adhesives, and material treatments used chemical knowledge that was later lost. These don't require advanced scientific understanding. They could be discovered through trial and error, carefully preserved recipes passed down through guilds or priesthoods. But they demonstrate that ancient doesn't mean primitive when it comes to practical chemistry. The pattern in technology. Ancient cultures achieved technological sophistication in various domains, sometimes exceeding what we'd expect for their chronological position. This could mean we underestimate ancient capabilities. Ancient people were as intelligent as us and achieved remarkable things through dedication, accumulated knowledge, and techniques that don't preserve well in the archaeological record. Some knowledge was inherited. Particularly sophisticated techniques might have been inherited from a predecessor culture, preserved as practical knowledge even if the theoretical understanding was lost. Development wasn't linear. Technology doesn't develop on a smooth upward curve. Civilizations can achieve sophistication in specific areas, then collapse, losing knowledge that has to be rediscovered later. The ancient world might have been more technologically diverse and advanced than conventional narratives suggest. All three explanations are probably partially correct. Ancient people were capable. Some knowledge was inherited and transmitted, and technological development was uneven, with advances in some areas and periods, regressions in others. The survivor. Hypothesis: what would they do? Let's engage in a thought experiment. Suppose there was a first civilization, a sophisticated, widespread culture existing during the Ice Age on now submerged coastal lands. Around 12,800 years ago, a cosmic catastrophe strikes. Comet fragments impact Earth, causing widespread destruction, fires, floods, and climate chaos. The civilization collapses. Most die, but some survive. What would survivors do? Immediate survival. First priority: food, water, shelter. The catastrophe has destroyed infrastructure, killed crops, disrupted food supplies. Survivors would focus on basic survival, using any available resources, reverting to hunting, gathering, and subsistence agriculture if necessary. Knowledge of advanced technology would be useless without infrastructure. You can't make sophisticated tools without workshops, forges, materials. You can't maintain written records if you're fleeing as a refugee. You can't preserve complex scientific knowledge if you're struggling to feed your family. Much knowledge would be lost immediately. Anything requiring infrastructure, specialized materials, or extended training. What could survive would be practical knowledge applicable in primitive conditions: plant identification, basic agriculture, firemaking, simple tool creation, oral traditions, social organization principles. Medium term: adaptation. As survivors established new communities, they'd try to preserve what they could of their former culture. Priorities would include oral traditions, stories, myths, songs preserving cultural memory, and important knowledge. Practical skills: agriculture, tool making, building techniques, healing knowledge, social structures, leadership systems, laws, conflict resolution mechanisms, spiritual practices, religious traditions providing meaning and social cohesion. Writing, if it existed, might be lost if materials for writing weren't available, or if literacy was limited to specialists who died in the catastrophe. Knowledge would be preserved orally, which is less stable than written records, but surprisingly durable. Oral traditions can preserve information for thousands of years. Teaching and integration. Survivors from the advanced civilization would find themselves among less advanced contemporary cultures. The hunter-gatherers and simple agriculturalists who didn't have the infrastructure that made them vulnerable to the catastrophe's full impact. Survivors might teach their knowledge to these cultures, showing how to cultivate specific crops, more effectively, demonstrating construction techniques for more permanent structures, sharing astronomical knowledge for calendrical purposes, teaching organizational principles for larger settlements, introducing artistic traditions, mythological narratives, religious concepts, but the teaching would be incomplete. Survivors wouldn't know everything from their former civilization. People specialize, and no individual knows all of their culture's knowledge. Teaching would be limited by language barriers, by the receiving culture's ability to understand and implement new concepts, by the practical constraints of what could be applied without the infrastructure of the lost civilization. The result would be pockets of relatively advanced knowledge appearing in otherwise primitive cultures, explaining sites like Göbekli Tepe, where supposedly simple hunter-gatherers built sophisticated megalithic structures, possibly because they were taught by or were descendants of survivors from a more advanced culture. Long-term legacy. Over generations and centuries, direct memory of the catastrophe and the lost civilization would fade, transforming into mythology. The survivors would be remembered as gods, culture heroes, or wise ancestors who taught humanity. The catastrophe would be remembered as the Great Flood, the destruction of the First World, the age of fire and darkness. Practical knowledge, agriculture, construction, astronomy, social organization would persist, transmitted through apprenticeship and tradition. But the context would be lost. People would know how to do things without remembering who originally developed those techniques or why. The result would be exactly what we see. Diverse cultures worldwide showing unexpected sophistication in specific areas, sharing similar mythological themes, building similar structures, possessing similar astronomical knowledge, but without clear connections or documented transmission paths, because the original source culture has vanished and its influence is preserved only in fragments. What physical evidence would survive? After 12,000 years, remarkably little. Stone structures might survive in eroded, scattered form, possibly unrecognizable as artificial coastal sites would be underwater, buried under marine sediment. Metal artifacts would corrode. Only gold, ceramics, and stone would persist. Written records would disintegrate unless sealed in extremely dry environments. Genetic evidence might survive, showing population movements and mixing. Mythological and cultural traditions would persist, transmitted orally. This pattern matches what advocates of the first civilization hypothesis claim: extensive cultural evidence, myths, architectural traditions, knowledge, but minimal physical evidence because of time, erosion, and submergence. The DNA evidence. Tracking ancient populations, recent advances in ancient DNA analysis have revolutionized our understanding of human prehistory, revealing population movements, mixing events, and relationships that weren't visible through archaeology alone. What DNA tells us. Ancient DNA extracted from skeletal remains and analyzed with modern sequencing techniques can reveal genetic relationships between ancient populations, population movements and migrations, mixing events between different groups, approximate dates of population, splits and convergences, origins of domesticated plants and animals. This technology has revealed surprising findings. Modern Europeans derive ancestry from 3 distinct source populations: Western European hunter-gatherers, early European farmers from Anatolia, and steppe herders from the Pontic-Caspian steppe, multiple waves of migration into Europe and mixing between populations. The Yamnaya culture from the steppes spread rapidly across Europe around 5,000 years ago, profoundly affecting European genetic makeup and possibly spreading Indo-European languages. Native Americans derived from a small founding population that crossed from Siberia into Alaska around 15,000, 20,000 years ago. Polynesians show complex ancestry, including Southeast Asian origins, with some genetic contributions from Native Americans, suggesting trans-Pacific contact. What about a first civilization? If there was a widespread first civilization that collapsed around 12,800 years ago, with survivors dispersing to various regions, we'd expect to see genetic signatures. A population bottleneck around 12,800 years ago, reduction in genetic diversity. Evidence of population dispersals from specific source regions, genetic connections between geographically distant populations that don't have obvious routes of contact. Do we see this? The evidence is ambiguous. There are population bottlenecks visible in human genetic history, but interpreting their causes is difficult. Bottlenecks could result from environmental catastrophes, from population expansions, when a small group successfully migrates to new territory, founding a new population, from disease, or from other causes. The major genetic patterns visible in ancient DNA: the spread of farming populations from the Fertile Crescent, the Yamnaya expansion, the peopling of the Americas, post-date the hypothesized first civilization's collapse. These patterns reflect known historical and archaeological cultures, not mysterious prehistoric civilizations. However, the genetic data is limited. We have ancient DNA from thousands of individuals, but this is a tiny sample from the billions of humans who lived in prehistoric times. We're sampling mostly from inland sites, where preservation is good. Coastal sites are underwater and inaccessible. Our genetic picture of the Ice Age and early post-Ice Age period is incomplete. It's possible that genetic signatures of a first civilization exist, but haven't been found yet, because we haven't sampled the right populations. Coastal sites are submerged. The signals are subtle, diluted by thousands of years of population mixing. We don't know what patterns to look for or how to interpret them. The pattern in genetics. Current genetic evidence doesn't strongly support the first civilization hypothesis, but neither does it definitively disprove it. The evidence is consistent with conventional narratives about human prehistory: dispersal from Africa, migrations into various continents, development of agriculture and its spread, mixing of populations through trade and movement. But genetic evidence from the crucial period, 12,000 to 15,000 years ago, is limited. This is exactly when the hypothesized first civilization would have existed and collapsed. We have some genetic data from this period, but not comprehensive coverage. As ancient DNA techniques improve and more samples are analyzed, especially from coastal sites, if underwater archaeology advances, we might find genetic signatures that challenge conventional narratives. Or we might find nothing, confirming that no widespread sophisticated culture existed during this period. The question remains open. The convergence. When coincidences become patterns. We've traveled the world, examining pyramids and megaliths, myths and mathematics, catastrophe and continuity. We've looked at structures, stories, and sciences across continents and millennia. And we've seen patterns, consistencies that are difficult to explain through pure coincidence or independent invention. Let's summarize what we found. Architectural patterns. Pyramids on multiple continents showing similar geometric forms. Megalithic construction using massive stones, cut precisely and fitted tightly. Astronomical alignments incorporating celestial knowledge. Mathematical relationships encoded in architectural proportions. Mythological patterns. Global flood myths with consistent narrative elements. Dying and rising god motifs across diverse religions. World tree concepts connecting cosmic realms, culture heroes, teaching civilization. Knowledge patterns. Sophisticated astronomy. Predating expected discovery. Dates. Mathematical knowledge appearing in unexpected contexts. Navigational capabilities allowing long-distance voyaging, technological sophistication exceeding conventional expectations. Geological context. The Younger Dryas catastrophe around 12,800 years ago. Sea level rise submerging Ice Age coastlines. Potential impact event creating global disruption, cartographic anomalies. Medieval maps possibly showing ancient geographical knowledge. Suggested awareness of Antarctica's ice-free coastline genetic and DNA considerations. Limited evidence from crucial time periods. Population movements and mixing visible in genetic data. Ambiguous patterns that could support multiple interpretations. Individually, each piece of evidence has alternative explanations. Pyramids could be independent invention of a stable architectural form. Megaliths could reflect ancient capabilities we underestimate. Myths could arise from universal human psychology. Mathematical knowledge could be independently discovered. Geological catastrophes could be natural climate events. Maps could be speculation rather than ancient knowledge. But taken together, the patterns suggest something more. The consistency across cultures, the precision in construction, the similarity in myths, the sophistication in knowledge, all appearing at time periods and in geographical locations where conventional history struggles to explain them. The simplest explanation that accounts for all the evidence is that there was a predecessor culture, a first civilization existing during the late Ice Age on coastal lands now submerged, possessing sophisticated knowledge of architecture, astronomy, mathematics, and navigation. This civilization was destroyed or severely disrupted around 12,800 years ago by catastrophe, possibly cosmic impacts, possibly climate change, possibly both. Survivors dispersed to various regions, carrying fragments of their knowledge and culture, teaching or influencing the less advanced contemporary cultures they encountered, creating the patterns we see today. This is not proven. The evidence is circumstantial, open to other interpretations, and hotly debated. Mainstream archaeology generally rejects the first civilization hypothesis, arguing that the evidence is better explained through conventional narratives of human development, independent invention, and gradual progress. But the hypothesis is also not disproven. It remains a possibility, one that accounts for anomalies and patterns that conventional narratives struggle to explain, one that ties together diverse evidence from multiple disciplines into a coherent story. The truth likely lies somewhere between the extremes. Perhaps there wasn't a single unified first civilization, but rather a network of relatively advanced Ice Age cultures that developed maritime capabilities, shared knowledge across vast distances, achieved architectural and astronomical sophistication beyond what we usually credit to Ice Age peoples, and whose achievements were largely erased by the catastrophes of the Younger Dryas and subsequent sea level rise. Perhaps the first civilization wasn't lost Atlantis with crystalline technology, but simply Ice Age humans who were smarter, more organized, more capable than we've given them credit for, whose main centers happen to be on coasts that are now underwater, whose knowledge survived in fragments preserved by their descendants. Perhaps the clues they left, if they left clues, are exactly what we've been examining. The architectural traditions, the mythological narratives, the knowledge systems that appear across cultures, not because of coincidence, but because of common origin, not because of independent invention, but because of inheritance from predecessors who knew these things and taught them to those who came after. The search continues. Where do we look? If the first civilization hypothesis has merit, what would we need to prove it? What evidence would be definitive? Underwater archaeology. The most promising location for physical evidence is underwater, on the continental shelves that were above water during the Ice Age. Comprehensive surveys of submerged landscapes using sonar, submersibles, and underwater excavation could reveal settlements, structures, and artifacts from Ice Age coastal cultures. This is technically challenging and expensive, but not impossible. Technology for underwater archaeology is improving, and several projects are beginning to explore submerged landscapes. Major discoveries could come from the Persian Gulf, which was a fertile valley during the Ice Age, Sundaland in Southeast Asia, a vast landmass now submerged, the North Sea and English Channel areas, the Black Sea, which was freshwater during the Ice Age, various coastal areas worldwide, where Ice Age shorelines are now underwater. Advanced dating techniques. Improved dating methods could help establish whether monuments like the Sphinx, Göbekli Tepe, or other structures are older than conventionally dated. Techniques being developed or refined include improved radiocarbon dating with better calibration, luminescence dating of stones, cosmogenic nuclide exposure, dating chemical weathering analysis, if major monuments could be definitively shown to be thousands of years older than conventionally dated, it would challenge existing chronologies and support the idea that sophisticated architecture existed earlier than acknowledged. Genetic analysis. Expanded ancient DNA sampling, especially from coastal sites if they can be accessed, might reveal population patterns consistent with a widely distributed Ice Age culture, migration patterns following a catastrophe, or genetic signatures of knowledge-bearing populations moving into various regions. Geological studies. Further investigation of the Younger Dryas impact hypothesis could confirm or refute whether Earth was struck by cosmic objects around 12,800 years ago. If confirmed, it would establish that a catastrophic event occurred at the right time to have destroyed an Ice Age civilization. Comprehensive surveys. Systematic surveys of ancient sites worldwide using modern remote sensing technologies, LiDAR, ground-penetrating radar, magnetometry, satellite imagery, could reveal previously unknown structures or connections between sites. LiDAR has already revealed massive, previously unknown structures in the Amazon, at Angkor, and at Mayan sites. Similar technologies applied globally might reveal much more. Interdisciplinary collaboration. The first civilization question crosses multiple disciplines: archaeology, geology, astronomy, climatology, genetics, linguistics, mythology, architecture. Progress requires collaboration across these fields, breaking down silos that currently separate disciplines and prevent comprehensive analysis. Orthodox archaeology tends to be conservative, and this is partly healthy. Extraordinary claims require extraordinary evidence, and we shouldn't overturn established narratives without solid proof. But conservatism can also become dogmatism, preventing serious investigation of alternative hypotheses. The ideal approach is rigorous but open-minded skepticism. Demand evidence, but seriously investigate possibilities that challenge conventional narratives. Don't accept the first civilization hypothesis without proof, but don't dismiss it without seriously looking for evidence that could support or refute it. Living with mystery. Perhaps the most important thing about the first civilization question isn't whether it's true or false, but what it represents. Our relationship with mystery, with the unknown, with the vast stretches of time and space that extend beyond our direct knowledge. We live in an age that values certainty, that wants definitive answers, that is uncomfortable with ambiguity. But the reality is that much about the past remains unknown. We have fragments, artifacts, monuments, myths, and from these fragments we construct narratives. But the narratives are always incomplete, always provisional, always subject to revision as new evidence emerges. The first civilization hypothesis reminds us that we don't know everything about human history, that massive gaps exist in our knowledge, that the story we tell about our past might be missing major chapters. This is humbling, but also exciting. It means there's more to discover, more to learn, more mysteries to unravel. Whether or not there was a literal first civilization, a sophisticated culture existing before recorded history, the patterns we've examined are real. Pyramids do appear worldwide. Megalithic construction does appear in diverse cultures. Flood myths are remarkably consistent. Ancient astronomical knowledge is sophisticated. These facts exist regardless of how we interpret them. The question is, what story best explains these facts? Is it independent invention by capable ancient cultures? Is it inheritance from a lost predecessor civilization? Is it some combination, Sophisticated Ice Age cultures achieving more than we've credited, their knowledge partially preserved and transmitted to successor cultures? We don't have to choose definitively. We can hold the question open, continuing to investigate, continuing to evaluate evidence, continuing to refine our understanding, and in the meantime, we can appreciate the monuments themselves, the myths themselves, the knowledge itself, regardless of where they came from. The pyramids are magnificent, whether built by dynastic Egyptians following their own innovations or following principles inherited from earlier cultures. The myths are meaningful, whether created independently or derived from common sources. The knowledge is impressive, whether discovered or inherited. The past speaks to us through these remnants, stones and stories, structures and songs, myths and mathematics. Whether they're clues from a first civilization or achievements of known cultures, they connect us to our ancestors, to the long human journey, to the creativity and capability of our species across thousands of generations. Closing. The trail of clues. As you drift towards sleep tonight, perhaps you'll think about the pyramids rising from deserts on multiple continents, built by people separated by oceans and millennia, yet sharing architectural visions. Perhaps you'll contemplate massive stones fitted together with impossible precision, moved by methods we still struggle to explain. Perhaps you'll wonder about the myths, those persistent stories of floods and fallen ages, of culture heroes teaching civilization, of worlds destroyed and renewed. Perhaps you'll consider that, beneath the supernatural embellishments, these stories might preserve real memories, transmit across vast stretches of time through countless retellings. Perhaps you'll look at the night sky as ancient peoples did and appreciate that they understood celestial movements with remarkable accuracy, encoding astronomical knowledge in their monuments, preserving cycles in their calendars, aligning their structures with cosmic events. Perhaps you'll recognize that the past holds secrets, that much about human history remains unknown, that the conventional narratives might be missing chapters, that evidence of earlier sophistication might be waiting beneath the sand, beneath the sea, beneath our assumptions about what ancient peoples could achieve. Whether there was a first civilization, a predecessor culture that left clues scattered across the face of the earth, remains an open question. The evidence is suggestive, but not conclusive. The patterns are intriguing, but open to multiple interpretations. The debate continues, with passionate advocates on all sides. But the question itself is valuable. It makes us look more carefully at ancient monuments, notice connections between cultures, appreciate sophistication in unexpected places, question narratives we've accepted without examination. It reminds us that history is not a closed book, but an ongoing investigation, that we're still discovering, still learning, still revising our understanding of where we came from. The clues are there, in stone and story, in myth and mathematics, in structures that have stood for thousands of years, holding their secrets. Whether they're clues from a lost civilization or simply evidence of our ancestors' remarkable capabilities, they're worth examining, worth wondering about, worth preserving. So sleep well, dreaming of ancient builders moving massive stones to precise positions, of navigators crossing vast oceans guided by stars, of storytellers preserving memories through endless generations, of knowledge transmitted from deep time into the present, waiting for us to finally understand what our ancestors were trying to tell us. The trail of clues stretches across the planet, from Egypt to Peru, from Turkey to Easter Island, from myth to mathematics, from catastrophe to continuity. We're still following it, still deciphering what it means, still discovering new pieces of the puzzle. And perhaps that's exactly how it should be. Not final answers, but perpetual investigation. Not certainty, but wonder. Not conclusions, but questions that keep us looking, thinking, seeking to understand the deep mysteries of human existence on this ancient planet. Good night, and may you walk through forgotten cities in your dreams, discovering what was left for us to find, connecting with the long, human story that extends far beyond recorded history, into times we're only beginning to glimpse. The first civilization, if it existed, is still teaching us, still leaving clues, still inviting us to see the patterns, to question the narratives, to imagine that humanity's story is grander, older, and more mysterious than we've been told. And whether or not that civilization existed in literal form, the spirit of the hypothesis, the recognition that our ancestors were capable, sophisticated, connected across vast distances and vast times, is worth preserving, worth celebrating, worth transmitting to future generations who will continue the investigation, continue following the trail of clues, continue asking the timeless question, where did we come from, and what wonders did our ancestors achieve that we've yet to rediscover? Sleep well, knowing you're part of this endless inquiry, this perpetual human quest to understand ourselves by understanding our past, to find meaning by tracing the threads that connect us to those who came before, to preserve the mysteries even as we work to solve them. The clues are all around us, waiting, and the search continues.